Hello, you're welcome to the Physics for Senior High School. This is a continuation lesson on our broad topic dimensional analysis. In our previous lesson, we did talk about a definition for dimensional analysis. Then we looked at some related terms. We left off by looking at the dimensional equation for area and volume. Today, our lesson specific objective is to continue to derive dimensional equation for some selected physical quantities. And we looked at this. We said we're going to derive all the dimensional equation for these quantities. But in our lesson previously, we focused on just the area and the volume. Today, we will start from the mass density and continue to the end. But let me effect this correction here. And the surface tension, this is what I gave you. For those of you who were writing, please kindly effect this correction. This was wrong. The actual thing should be m c minus 2. Later in the video, we will prove why it is so. So stay tuned as I switch over from this presentation board to the writing board. Great. So now let's start at mass density, whose dimensional equation is written as ml exponent negative 3. How was this gotten? From its expression. Now, mass density is expressed as mass per unit volume. That is mass over volume. So, from henceforth, all the expressions have to be given or stated before we can find their dimensional equation. Moving forward, the dimension for mass has the unit m divided by the dimension for volume in our earlier lesson was L exponent 3. With this, it could now be written in the linear form for L exponent 3 to go up, and that will be m. It is positive while a denominator. When it comes up to join the numerator, it will go negative. So mass density has its dimensional unit or equation to be ml exponent negative 3. That is why. Let's proceed to area density, whose dimensional equation is ml exponent minus 2. It is so because area density is expressed as mass over area. Converting them to their dimensional unit, that of the mass is m over area L square, just as we looked at it previously. If this is now written in the linear form, it will be m L exponent minus 2. That is that for area density. Now to linear density, ml exponent negative 1. So I hope you have noticed that we have linear density, area density, and mass density. Most students are used to the mass density because for short it is called density. But don't forget the area as well as the linear density. Now for the linear density, it has its expression as mass over length. Mass has the dimensional unit m and that of the length L, and the exponent is 1. If this is written in your linear form, it will be ml exponent negative 1. So that is that for the linear density as well. Now to velocity or speed. It is Lt exponent negative 1. It is so because velocity is expressed as displacement over time taken. In our lesson, I mentioned that displacement has a dimensional unit as length, and so that is represented with L. That of the time is a t. When this is written in the linear form, the t carries a positive 1. And so it comes up to become negative 1. So this is how the whole thing was proven. Passing forward, we look at acceleration, which is Lt exponent negative 2. Acceleration, in fact, is expressed as the rate of change of velocity with time. That is velocity with time. Here, you could go on and express the velocity also as displacement over time. Or simply we have earlier looked at the velocity as this Lt negative 1. So you could replace it and move ahead. So velocity become Lt exponent negative 1 all over t for time. As this is also done, written in the linear form, you will have it as Lt negative 1 times t. This is carrying a positive 1. When it goes up, it becomes negative 1. Per the rules of indices, this t and t have the same base and multiplying. Once it's multiplying, the exponents are added. That will amount to negative 1 plus negative 1, giving negative 2. That is why acceleration has Lt exponent negative 2 as a dimensional equation. Now to force, whose dimensional equation is mL t exponent negative 2. It is so because force is expressed as mass times acceleration. Now mass has a dimensional unit as m times acceleration, which we just found to be Lt exponent minus 2. When multiplied, you will have m Lt exponent 2. That's negative 2. And please, we are laying a solid foundation for deeper understanding of this topic. So you have to really follow, understand how each of the dimensional equation was proven, and learn to keep this in your memory as well. Work or energy, which is expressed as ml exponent 2 t exponent minus 2, because work is force times distance. Now, force has already been expressed here as mLt exponent negative 2, so I will quote that. Multiplied by distance, which expresses length, and so that is also an L. By the rules of indices, These L's have power of 1 each and they are multiplying, and so the exponents are added, and that will amount to L exponent 2 T exponent minus 2. This is how the dimensional equation was gotten. Now to power. Power is expressed as L exponent 2 T exponent negative 3, because the expression for power is work done over time. But work done has been expressed as L exponent 2 T exponent negative 2. So we will only quote that. All divided by time, which has a dimensional unit as T. This in the fractional form, written it in the linear form, T will have to go up. So that will be times the T carries a positive number. When it goes up, becomes a negative 1. Now, still by the rules of indices, this T and this T are multiplying, and so the exponent will add, and that will give ML exponent 2 T negative 2 plus negative 1 is a negative 3. Now to pressure, otherwise called stress, which has a dimensional equation as ML exponent negative 1 T exponent negative 2. Pressure is expressed as force over area. In our previous lesson, we did look at the force to be MLT exponent minus 2, and so we will quote that MLT exponent minus 2 all over area, which is L squared. Now with this, the L will join the numerator to be on a linear form, and that will be MLT minus 2 times L exponent minus 2. With the roots of indices, this ML here carries a positive 1, while this carry a negative 2. When added, you will have negative 1 and T negative 2. That is why its dimensional equation was expressed as this. Thank you. Moving on, let's now look at impulse. MLT exponent negative 1. Friends, impulse is expressed as force times time. Force, as already established, has the dimensional equation as MLT minus 2 times the time, which is T. Using indices, this T carries a positive 1, this is a negative 2. When multiplied, the exponent will add, and that will be MLT minus 1. So that is the dimensional equation for impulse. Okay, now to momentum, which has the dimensional equation MLT exponent negative 1, similar to that of impulse, because impulse is actually changing momentum. As you go along your course in physics, you'll come to appreciate all of these. Now, momentum is expressed as the product of mass and velocity. Writing their dimensional form, mass has the dimensional unit as m multiplied by velocity, which we earlier looked at here as m lt exponent negative 1. Okay, so when that is quoted, we will end up multiplying these two, and we will get m lt exponent negative 1. Great. We are left with about 4 more to complete. Now to moment of a force, which has the dimensional equation to be ml exponent 2 t exponent minus 2. Moment of a force actually is equal to the product of the force and the perpendicular distance. Now force, as already established, has the dimensional equation ml t exponent minus 2. Then perpendicular distance expresses length, and so it has a dimensional unit to also be L. Remember that this L carries an exponent of 1. This also has 1. When multiplied under the rule of indices, the exponents are added, and that will be m L the power 2 t exponent minus 2. So that is how it was gotten. Thank you for staying up to this far. We have 3 more to end. Now to surface tension, which has a dimensional equation m t exponent minus 2. The surface tension is expressed as force over length. Now force is m L t exponent minus 2 all over the length, which is L. If you look at critically, the length will cancel out, and you will be left with m t exponent minus 2. So that is the dimensional equation for surface tension. Friends, let us then look at frequency, which has a dimensional equation as t exponent minus 1. You see, frequency, as you will later find under wave motion and simple harmonic motion, is the reciprocal of the time period. So it is 1 over period. Now, period here simply means time, and time has got a dimensional unit as t. When this is written in the linear form, it carries a power of 1. When it comes up, it becomes t exponent minus 1. So that is it. And now to the last for the day is coefficient of viscosity, whose dimensional equation is m L exponent negative 1 t exponent negative 1. In fact, coefficient of viscosity has this formula as the product of force times distance all divided by product of area and velocity. Okay, so going through force, by this time I trust you have kept it, has a dimensional equation as m L t minus 2. If you said that right, good. Times distance, which is also a length, that is L. All of this divided by area, that is L exponent 2 times velocity, L t exponent 1. Just work on the numerator first, because there is an L with exponent 1, another L with exponent 1. When multiplied, you have m L exponent 2, then t exponent minus 2. Working on the denominator, there is an L with exponent 2, L with exponent 1, and that will be L exponent 3, then t exponent minus 1. With this understanding, we now write this in linear form. That will be m L exponent 2 t exponent minus 2 times, because this is going up, the power from positive will change to negative, and that will be L exponent negative 3. Then the t, which carried negative, will now be positive 1. You look for common terms to multiply. So m comes here. Now L exponent 2 and L exponent 3, while multiplying, the exponents are added. So that becomes 2 plus minus 3, which gives negative 1. With a t, you will have negative 2 plus 1, which also gives negative 1. So that is the dimensional equation for the coefficient of viscosity. Thank you very much for staying up to this far. You have been very good for staying attentive while we proved all these 16 physical quantities, looking at their dimensional equation. And as I earlier said, this will prepare you for subsequent questions as we look at the validity, proving of units, as well as forming dimensional equation. So I beseech all students to know these 16. They lay the foundation for a greater work for future. Thank you very much. Stay tuned and be blessed.